So, fun with functional JavaScript. But first, a bit about me. My name is Kuba, and I am a C# web developer, which is odd at this conference, I realize, but please don't kill me yet. Because, you shouldn't kill me, because I'm intrigued by F# and actually by the whole functional programming movement that's developing quite fast lately. And I'm also a JavaScript enthusiast, hence this talk, functional programming and JavaScript merged together. I'm also quite a conference junkie lately, and I'm on a bit of a streak, so I've been to a few and I really like this. So I'm really happy that I can be here and talk to you today. And I'm really happy also to be able to take part in the conference, because I'm expecting to learn a lot from the other speakers. So far it's been great here, and we're still not even halfway through the conference, so I think it's going to be even better. I'm working at ABB, but not in Krakow, in Łódź. So in the very center of our beautiful country. And if you want to contact me later on, you can find me on Twitter at Kuba Waliński. You can email me, and you can also have a look at my blog if you want to read something more. So the topic for today: fun with functional JavaScript. Can you hear me at the back? Am I loud enough? Yeah, more or less. Okay, I try louder. So, fun with functional JavaScript. Who has been to the keynote? Okay, so seriously guys, no more slapping. I've been slapped a few times. It's not fine, it's not nice. Just first hear me out. I will lay my case, and you can judge. And if you're not convinced that JavaScript is even a tiny bit functional, then you can slap me. But that's at the end of the talk. Okay. In general, a short introduction to this actual talk. So it was the initial concept was to introduce functional programming to JavaScript developers, but here we're obviously working the other way around. So we have functional programmers who probably are not that much interested in JavaScript. Maybe I'm mistaken. Who's using JavaScript here? Okay. So it's more than half. But for those who are not, so I'm trying to shift the emphasis of this talk a bit to have functional programmers in mind and try to convince them that JavaScript is not that bad. So that's why I'm gonna go quite fast through this slide, because I think you should know all those ideas in functional programming. So functions as first-class citizens, pure functions, immutability, why recursion is important. Those are just a few items from the functional programming paradigm that I want to highlight, because I will now contrast them with JavaScript, and I will explain how those ideas are implemented in JavaScript and how you can make use of them. So, JavaScript is a bit functional, because it has first-class functions. So you can have a function that is returning another function. You can pass the function as a parameter. You can store it in a variable. It's a first-class citizen in the language. Functions can also have closures, so they can remember the state of the environment and use it later on, even after they have returned. You can also use anonymous functions or lambdas. And that's where the happy path really ends with JavaScript. Then you have a bit of a pain, because if you want to have pure functions and immutability, like you would expect in a functional programming language, then you have to take care of it yourself, because the language will not help you, because obviously by default all the variables are mutable, and the functions are not. There is no any specific safeguards to ensure that your functions are pure. And also, when it comes to table optimization, if you want to do some recursion, that's not supported at all in the language, and not much you can do really about this. But the good news is that the support is coming, and I'll be talking more about this towards the end of the presentation. Okay, so that's the brief introduction, and now it's time to see some code. So we'll start obviously with a hello world. And so in this case it's a bit of a twisted hello world. So I call it world hello because I wanted to demonstrate some of the functional properties of JavaScript. So I just defined a function that is concatenating two strings. So I could have done it simply like this. Can you see the code at the back? Is it okay? No? Okay, so just give me a second and I'll increase the font size. Is that better or even more?
Can you turn on the lights?
Excuse me?
Can you turn off the lights?
Turn off the lights. Can we? I don't know because we're recording.
It's behind the desk.
Mikrofon jest włączony.
Okay, and size-wise, is it okay? I assume it's okay. No protest. So, it is hard to see still.
Maybe use the presentation mode.
I need to use the terminal. So.
Okay.
Spróbuj teraz.
Hello. Oh, turn it off and on again. Apparently. Okay, how does that look like? Guys? Bigger, okay. one last increase.
Something like Zoom in Windows. Window presentation mode or something. Windows plus.
Yeah, I know. I can zoom in, but then there will be too bad. Okay, so I'll decrease the font size a little bit and then I'll be zooming. Good?
Yeah,
Good? Okay, sorry about that. So, you could concatenate two strings like a normal person with just the plus operator, or you could use a join function on an array if you're cool and functional. So that's what I'm going to do. And then also you can pass the arguments to a function in the order that you want them, like here. First the function and then A and then B, but you can also flip them because you're cool. So you can just take a function and two arguments and pass those arguments in reverse order. And that's how you create a hello Lambda days function. Well, by composing those two little functions that I created. Okay. And prove that it's working. As you can see, hello Lambda days. So hello. So now to the main premise of this demo. I've created a little function that is pretty simple, and ideally you should be able to tell what it's doing instantly. But my experience shows that rarely happens because that's just a for loop, some variables that are created in place, then an if statement. You have to really figure out what's going on. And what actually happens here is we take an array and we just make sure that all of the elements in this array are either 0 or negative. So a pretty simple task. And the implementation, I think, should be also a bit simpler than this. And we can obviously make it much simpler if we use some functional programming tricks. So I'm importing this function do something because I'll be using it to compare if my result is the same. with this initial implementation. But now I will try to implement the exact same functionality with some functional programming magic. So first, obviously I need a function map that will just go through an array and apply a function to each element of the array. And there is a function map in JavaScript, but it's attached to the array. And so somehow I have to make it more generic. So I'm just creating a function map for my own use, which is taking an array and a function that is supposed to be applied to each element, and then is just calling map on this array with this function that was passed. So pretty simple stuff. And then, one more thing about map. So the order of arguments obviously is pretty important, because my ambitious goal is to have this function be able to implement this function that does something in one line. So the order of arguments will be important because I would need to use carrying. So I would like to, pass arguments one at a time to this function to this map function. So that's why this is the default order, that I pass the array first to the map and then I pass the function. But that might not work for me. Because I first would like to pass a function and then have the map function ready to accept an array. So that's why I need a flip function that will just take a function. It will take two parameters a and b, and it will call the function that was initially passed with the same parameters but in a reversed order. So by combining those two functions, I will have a map function that first will accept the function that will run on all the elements of the array, and then it will wait to receive the actual array that it will operate on. And here are some examples how the flip function will actually work. So as you expect, nothing really that interesting here. And then, as I mentioned, I will need a carry function to partially apply the map function. And so the carry function also quite simple, takes a function, then takes the first argument, then takes the second argument, and once all those elements are passed, we run the initial function with those two arguments. And again, examples are pretty easy, I hope, pretty easy to follow. So I guess you can read, all of you can read, so I think it's easy to grasp, unless it's not, so please ask your questions if you have any during the talk. So we've got the building blocks ready, almost all of them. So we have a map function. We're able to flip the order of arguments in the map function. We have the carry function, which will allow us to partially apply the map function. Now we need some mathematical functions that will actually do the negation of our elements. So we've got a negate function that will just return -1 times the argument. And we've got the absolute value, because obviously if we want to make sure that it's a negative number at the end, we first do absolute value and then negate it. And finally, one last trick that we need is to be able to compose functions. So I created a simple compose function that takes two functions, f and g, and it then waits for the argument, and when the argument is passed, it returns the result of invoking the function g and then invoking the function f on the result. So it's pretty clear also. I really like the fact that it's a really nice mathematical notation of the type that we're all familiar from primary school and secondary school. So it's all pretty easy to follow, I guess. Or at least that's what I hope. I don't see any questions yet, so I assume that you follow. So again, some examples, how you can use the compose function. And finally, we've got all those building blocks. And now this is how I suggest that we could implement this function that negates, well, not really negates, but make sure that the resulting array is all negative or 0. So what we have? as I told you, we have a map function because that's obviously the basis, because we want to do some operation on each element of the array. But it's not, the order of arguments is not correct for us, so we use a flip on the map. So we can first pass the function. So now, after flipping, the map function first is taking the function that will be executed on all the elements. Then we use the carry, so the map function will take the function argument first. And actually the function argument is a compose function which first does absolute value and then negation. So basically we have a function that has a map function built in, already knows which function it's supposed to execute on each element of the array, and is waiting to be passed the actual array to operate on. So this is the test data that we'll be using. As you see, some numbers are negative, so they shouldn't be changed. Some are positive, so they should end up negative in the result. So I'll first log out the actual test data, and then I'll log the result of running the initial function that you saw, that was an imperative style. And then I'm going to log what I've just created here, the function that I've just created here, and the result of running it. So, and as you can see, the results are the same, so...
-0.
Oh, that's interesting. Didn't see that before. Okay, but -0 is still 0, right? That's because JavaScript. It's probably got confused which operators to use. Okay. But it'll be interesting to investigate next time. Okay, so this is more or less how you could use functional programming style in JavaScript if you just use plain vanilla JavaScript. It involves a lot of tedious work creating those tiny functions and flipping arguments and doing a lot of repetitive tasks, and at least until to the point where you've already got your full library of tiny functions that you can reuse and compose them, etc., etc. But if you don't, if you're just starting from scratch, a better idea might be to use a library that provides useful functions that will be helpful. And one such library is called Lodash. It's actually a part of a pretty popular _JS library. And the name underscore comes from the fact that you invoke it by using the underscore, and then dot and the function that you want to use from the library. And it provides loads of those useful functions that you can use to manipulate arrays, collections, functions, and objects. And in the context of the task that I want to achieve here, it's pretty useful because it supports carry and partial application. So it should be a bit easier to code this function that I want to imitate a bit easier than in plain vanilla JavaScript. So this is the code. I load the Lodash library. I load the doSomething function, obviously. I still gonna need the negate and absolute value functions because they are related to the actual logic of my application, and I have to provide them myself. But I don't need to create a carry function because it's already in Lodash. I also don't need compose. Unfortunately, I don't have a flip function, so I wouldn't be able to control the order of arguments when I want to carry. That's why I'm not going to carry, because I have a partial write function, which in this case will do exactly the same because it will partially apply the arguments to my map function from the right, so in the opposite direction. So it will do, for me it will do the same as a combination of carry and flip did in the previous example. So, negating all in Lodash, a bit simpler, as you can see, because I'm partially applying from the right to the function map, I'm passing a composition of negate and absolute value. So that should look already pretty familiar, but I guess we'll agree that the syntax is a bit nicer and easier to follow. But I think we can do even better, but you'll see it in the next attempt. But for now, let's see if this actually works. -0 again, obviously. But apart from that, it seems to be okay. So that's Lodash for you. And this more elegant and more concise way that I was mentioning would be achieved using the Functional.js library. Functional.js is actually a funny story because how I got to know this library, because it's not one of the most popular ones, but I really like the features that it has, so I've grown to like it. So I was, as I told you at the beginning, I was interested in functional programming, and then came the time when I got really deep into JavaScript, and one day an idea popped to my head: wouldn't it be awesome if there was a functional programming library for JavaScript? So I obviously didn't look if there is already one, because it would not be exciting. It would be exciting to create one. So I wanted to create one, but first you need a domain name, obviously. So .js is not really an extension that you can use. So I figured out, the best idea probably would be functional.js.com. So I'm gonna have a look if it's available. So I typed functional.js.com, and I found this library. So I was a bit bummed because not only did they use my domain name, but they already created the library that I wanted to create. But I had a look at the tutorial where the author shows all the features of this library, and it turned out that it's a really nice library, and maybe it's better to just, because it was open source, so I figured out that it's better to contribute to what Lee Crossley has been doing than to start something on my own. So Functional.js, Lee Crossley, he's constantly developing and using it on his own projects. It's got a bunch of downloads every day from NPM. For the purpose of this talk, what's interesting is that carrying in this library is implemented by default. So each function that you use, you can by default either pass all parameters or pass them at once, or pass the two first and then another one and then another one, which will be very useful, as you can see in a moment. And also, what I've been struggling with is the parameter order. If you've seen, I had to either use partial right to apply them from the right, so in the opposite order, or I had to use the flip function to invert the order of parameters. And in Functional.js, the map function has the correct order that you want to use if you're going to partially apply. So the map function first takes the function and then the array that it will operate on. So it's just a little thing, but it's really, really helpful, and you can see that it was well thought out. So coming back to the code, making sure that you can see. I'm, again, importing all the stuff that I need. I'm defining my helper functions.
You still need negate and absolute? There's no library for that? Or?
No, probably is, but just for completeness.
Okay.
Just so that we can get -0 to be concise. So I'll use this. So, as I mentioned, we've got a carry function that's available in Functional.js. And we can have a simple function that performs addition, and we can pass it to the carry, and then the carried function can obviously accept the parameters one by one. It can even accept, once you carry it, it can accept more parameters that you initially defined. So it's also a pretty nifty feature. It's called arity, the number of parameters that you accept. And in this case, you can arbitrarily extend the arity. So to this carry that function, I can now add 10 parameters or 1,000. And it will figure it out. and it will add all of them. So that's pretty cool. But as I said, the map function is carried by default, so I don't even need to use the carry function, and I don't need flip because the order of parameters is exactly how I need them. So the only additional thing that I need is a compose function, just to make sure that I can compose the absolute and negation. So once I have all this, I just compose the function that I want to apply to each element by composing absolute value and negation, and then just pass it to the map function. And the map function accepts this function, this compose function, as the one that is supposed to be run, and then waits to be passed an array. And that's exactly what I'm doing here. Again, displaying the test data, and then displaying both results. And let's have a look. Yeah. So, yeah. It's all pretty correct, right? Okay. So that's Functional.js. Yeah, it's a feature. Come on, it's JavaScript. Don't be so hard on it. Yeah, so that's those are the two libraries that I really recommend if you need to do JavaScript and if you don't really like it and you would like to make it a bit more functional. So I think that they are pretty perfect for this task. But also the good news is that the ECMAScript committee, so the standards body that works on JavaScript and adds new features to the language, they are also quite keen to extend the language, and some of the extensions and additions that are coming in ECMAScript 6 are pretty functional in nature, like arrow functions. So this is just a simpler way to define lambdas, so functions that you can define in place. And you'll finally also have tail call recursion optimization, so you won't run into Stack Overflows if you have too deep recursion. Of course, if you have tail calls, if the recursion is implemented correctly. And there are also those three other features that are maybe not that functional in nature, but they are pretty cool and simplify functional programming in JavaScript. So I also wanted to show them to you. So now, a little disclaimer for this to work. Obviously, ECMAScript 6 is not yet implemented in browsers or in Node.js that I'm using to run the examples. So I'm using what's called a transpiler that allows me to write code in ECMAScript 6, and then it transpiles it to ECMAScript 5 that can be run by Node. But it's basically equivalent to what we will get in browsers once the standard is approved. It's supposed to be approved somewhere in the middle of this year. So it's a good tool to show what's coming, and it's pretty accurate because the standard is already finalized. But first, I mentioned recursion, and this cannot be achieved by transpilation because it's a really low-level feature of the JavaScript engine. So we have to look for some workarounds, and we can use one, a really nice one that I really enjoy, which is called the trampoline. And the trampoline is a way to deal with recursion by delaying when the function is executed. So usually, if we have a factorial function, obviously, when you present recursion, here instead of returning a function that performs the recursive call, instead of calling, I just return a function. So then it's my responsibility if I want to calculate the factorial of 3. Obviously, I have to pass 1 as the initial value for the accumulator, because then it will be multiplied correctly. But then, if I want to calculate the result, I have to execute the function 2 times, because first the argument is 3, then the argument is 2, and then the argument finally is 1, and it will return. So this is not really useful, because the number of of parentheses pairs here are dependent on the argument, so it's not a really useful function. But there is a workaround, and this is actually the trampoline. So the trampoline will take any function, and while it still returns the function, it will call it. And we'll call it again because it's still a function, and again. And once it's not a function, it will return. Once it's finally returned a value. So it can be arbitrarily complicated, the call chain, but the trampoline will work this out for you and will provide a value at the end. And we can use this trampoline value likewise by calling the jumping factorial with the parameter. And it should all work out. And let's actually see if it does. Yeah, so you see the first call was this. Where is it? The first call console log was here, so it was the factorial of 3, and I had to execute the function 2 times to get the result. And then when I use trampoline, I just pass 4, and I don't care about the function execution because the trampoline does that for me. And then I get 24, obviously. Some more of those features that I mentioned. So this is those are arrow functions that you can just define in place. That square is a function that takes an x and returns x times x. So it's obviously you don't have to do this. So you don't have to do function and then open the body of the function and say explicitly what is returned. So it's just a little syntactic sugar, but it's going to be very useful when you program functionally. And then also a useful feature, you can decompose or destructure arrays and objects. So you can just define variables and define in place that the first, second, and third arguments should be put into those variables. And you can do actually the same with objects. And the missing element here is going to be undefined. And let's actually see that. Okay, arrow functions, that's not that, sorry. Yeah, so as you can see, it's 1, 2, 3 and 1, 2, 3 undefined because it correctly decomposed or destructured the array and the object. And finally, a pretty cool addition to the language as well. You have a function that accepts some parameters as a sort of a list, just a list of parameters that it accepts, but you have those parameters in an array. So previously, well, in ECMAScript 5, you have a way to do this, but it's a bit tedious, and people sometimes find it hard to do. And there is a lot of questions on Stack Overflow how this works. But now you just use the triple dots here, and the array is automatically spread, and you can just call the function. So also a bit of syntactic sugar that will make all our lives much easier. And for the final bit of demo, trying to put it all together and showing one more feature. So the premise is that we need to write a function that accepts a variable number of parameters. And the first parameter is the tag that it's going to log, and then there are the messages. And each message should be logged with the tag that's been passed in first. So in ECMAScript 5, if we want to achieve this, we can pass the tag as the explicit parameter, but then to get all the other ones, we need to use the arguments object, which holds all the arguments that were passed to the function. But we pass in one at the end to skip the first one because we already have it. And then for each log that we have, we just log it to the console. So then it's pretty straightforward. And in ECMAScript 6, we can again use the triple dots here. So we don't need to look at the arguments array like above we had to. But in this case, the first argument will be called tag, and all the other arguments that are passed will be pushed into an array that's called logs, thanks to those triple dots. And then the code is the same. But finally, as you've seen arrow functions, we can also do it like this, do it even shorter. So it's actually a double arrow function notation. So first the log tags with short, those are the arguments, and it returns a for each. And the for each actually has a function that takes log as an argument and returns something to the console. And that's it. So I don't know if you would agree, I hope you will, but pretty nice features, and they will make the code simpler and easier and nicer to write. So that was, hopefully, at least for me, it was quite fun doing this functional JavaScript talk and showing you the code. Those are the resources. So in the shortened bit.ly, you've got a link to all this talk, the code, and the slides that I've put on GitHub. If you're interested and don't have anything to note it down, I will also tweet it after this talk, so you can find it there. And you have links to all to those libraries that I've shown, Lodash and Functional.js. And you've got links to two very interesting books on the topic, one by Michael Fogus and another by Raganvold. And also a video from NDC where Raganvold presented the ideas from his book. So, in conclusion, as I stated in the title and repeated throughout the talk, to my mind it's pretty fun to do functional programming in JavaScript. Mostly, I think, because you wouldn't expect that you could do this if you don't know JavaScript that well. But turns out it was based on some pretty interesting functional programming concepts, and it shows, and you can take advantage of that. So it's really a new way to look at the language when you approach it from this side, and it's also rapidly developing because you have new frameworks, new libraries. They make use of those features, new language features that come up, and there are more functional programming features waiting for ECMAScript 7 as well. So, summing up, if you're a functional programmer and you need to do something in JavaScript, just give it a chance. Obviously, it's never going to be as good as a strictly functional programming language, but hopefully for some of the tasks that you need to do, it will be good enough. So that's it. That was functional JavaScript. So now if anyone still needs to slap me, I'll be available after the talk. And if you have any questions, now is also, we have a few minutes to discuss this. Yes?
Maybe regarding one of the last points on slides, did you try to use JavaScript or Scala.js and have some thoughts about that?
I tried. I did some experiments with Clojure script, but not enough really to weigh in. Also, I didn't participate in this talk that was here before. I heard it was quite interesting. So for now, I really like JavaScript, so I prefer to write in it. But obviously, if you're already familiar with Clojure or with Scala, and there is an option to compile to JavaScript, it's probably also a good idea. If you need to do something in JavaScript, and let's face it, JavaScript is becoming more and more popular, so it's more and more likely that you will need to do something with JavaScript at some point.
Or less likely, you have like ability to.
Yeah, less likely because you can compile, but then if the compilation is not up to scratch or something, then you have a bug that you cannot really resolve because you don't know what's going on. Just some magic happened, it's compiled, you get some JavaScript that you don't understand, and you cannot debug it. So that's why, for those reasons, for now I'm sticking to plain JavaScript. Does that answer your question? I hope. Okay, any more questions?